Hi everyone, welcome to NCKHUB. Today in our video we are going to cover insertion sort algorithm as part of data structures and algorithms. So first we'll see what is insertion sort. So insertion sort is a simple method for sorting the numbers either in ascending or descending order. So basically it follows the incremental method and it works based on the comparison based sorting algorithm. So here one sub array list, or we can call sub list, which is always a sorted one. So here we are going to maintain one lower part of array. So that which we need to maintain it as a sorted order. And whatever the element we want to insert into sub list, so has to find its appropriate place, and then it will be inserted accordingly. So here elements will be searched in sequentially and unsorted items are moved and inserted into the sorted sublist. So basically this is not suitable for the large data sets. So next we'll see algorithm. So how this insertion sort algorithm works. So the first step is like we'll take the first element in the array as a sorted one. So and we are going to take that element and place it in the sorted array list. Okay, and then we will be taking the second element and we'll start the comparison. So now we are going to compare the key with all the elements in the sorted array. So if the element is found to be smaller than the current element, then we are going to move to the next element. Otherwise we are going to swap the elements and move to the next elements for the comparison. So that's how we are going to proceed in this insertion sort algorithm. So we are going to repeat this until the array is sorted. And yeah, so first steps is like algorithm, and second we can see the pseudocode for this insertion sort algorithm. So basically we are going to take from the second position to the length of the array, and then we are going to take key element, so which is like second element, we are going to take it as a key element, and then we'll do the comparison. So whenever we feel like uh, greater element is present in the first index, then we are going to swap the elements and accordingly, so we are going to repeat this process till the arrays gets sorted. So here we'll see like working of insertion sort algorithm. So here for sample, like we are taking this array which has elements 13, 28, 26, 7, 31 and 16. So as per the algorithm, like we are going to treat that first element is like a sorted one, and then we are going to compare with the next element. So like this, we start comparing with 13 and 28, and basically these two are already in sorted, so we need not to swap or doing anything. So next we are going to do the comparison with the next two elements, 28 and 26. So here 28 is greater than 26, so swapping of these two elements is required. Once we swap it, so the elements will become 13, 26, 28, 7, 31 and 16. So already we have taken like first element like a sorted element. Okay, sorted into sorted list or sorted array we call. So and then we are going to compare this 26 and the sorry. So okay, so 28 and 26, like these elements got swapped, and we can see 13, 26 in the second position, and then we can move to the, and we need to check the sorted list. So 13 is there and 26 after the swapping. So these two are already in sorted order. So then we are moving to the next element comparison. So that is 28 and 7. So these two are not sorted, so we need to swap them. So we can swap it. So then now it will become 13, 26, 7, 28, 31 and 16. Okay. So now we need to comparison with the sub-array list. Okay. So which is a sorted one. So now here we are comparing 26 and 7. so which are not sorted. So we need to swap them. So after swapping, it will become 13, 7 and 26. Okay, 13, 7 and 26. So again, it is going to do the comparison with the first element, like 13 and 7. So again, these two are not in sorted. So again, now we need to swap the elements. So it will become 7, 13 and 26. So now all these three elements are in sorted. Okay. And this is in the sub-array list. Okay. And next we'll do the comparison with the next two elements like 28 and 31. So we are doing the comparison of next two elements 28 and 31. So these two are already sorted. So we need not to do anything. So we'll go for the next set of elements like 31 and 16. So now these two elements require swapping. So we will swap it. So elements will become 7, 36, 26, 28, 16 and 31. So again, now we are going to check with one step like 28 and 16. Again, these two require swapping. So it will become 7, 36, 26, 16 and 28, 31. So again, it is going to do the comparison with previous element. So that is 16 and 26. So again, these two require swapping. So it is going to do the comparison between 26 and 16. Again, this requires swapping. So we can swap it. So we can see 7, 13, 16, 26, 28 and 31. So now the array is sorted. So there is no further iteration or check is required. Yeah, next we'll see like what is the complexity involved for this insertion sort. So the best case is like order of n. So that means already given array is a sorted one. So still if you try to execute, so it will take n iterations. Okay. And average case like so we can see like array elements are in jumbled order. So that is not properly ascending, not properly descending. So in that case, it is going to do order of n square. Okay. So and worst case like the given array is in reverse order and you want to sort it in the ascending order. So that is the worst case and that is also time complexity is like order of n square. And coming to space complexity, it is around order of 1 because we need one temporary variable for swapping the elements. So next we will see with Java code to implement this insertion sort algorithm. Yeah, so here it is a sample demo class for insertion implementing insertion sort algorithm. So here I have taken one int array like with some elements 92, 50, 5, 20, 11 and 22. So these are my elements and I want these elements to be sorted in ascending order. So I just added one statement before sorting what are all the elements. For that I have created one method display array. So basically this is going to iterate our array and then just printing these elements. And after that I am calling this insert sort algorithm. Okay, sorry, insert sort method which has the implementation. So here I have taken initialize three variables int I, j and temp and I am getting the length of the array and then iterating the array. So for I equal to 1, so I less than n, I plus plus. So I'm just iterating and then taking the temp equal to number 4. So here I'm taking like that first element is the uh, uh, it's like a key element. Okay, and then j equal to I minus 1. So which is like j equal to 0 and j greater than equal to 0 and temp less than or equal to. So here what we are doing is like we are moving the elements and checking whether the temp element is whether the element is greater than temp or not. Okay, so if it is if temp element is less than element, then we are swapping the positions. Okay, num j plus 1 equal to num of j. So here we are doing that swapping, and then okay, and then first we are swapping, and then we are again doing that iteration. Okay, so after sorting, so again I am printing the elements. So first we will see how it is going to display. So just run it. So these are the elements before sorting: 92, 55, 20, 11 and 22. So after sorting, so the lowest element will come first: 5, 11, 20, 22, 50 and 92. So here we will see like how the elements are sorted. So I'm just trying to print this array after every iteration. Okay, and just run it. Okay, so as we seen in the working of the insertion sort algorithm, so here we can see 92, 50. So these are the elements we are given. So first it is going to do the comparison 92 and 50. So and here we can see those two got swapped and rest of the elements same. After that again we are doing the comparison like 92. Uh, So yeah, once it is got swapped, and then we are doing the comparison 92 and 5. So again sorting is required. So swapping will be done 5 and 92. So 92 got here and 5 will come here. So yeah, again this sub array list. So it will be sorted accordingly. So if you do compare like 5 and 50, so 50 is here and 5 will be here after swapping. So again it will be sorted. So that's how 5, 50, 92, and then other portion will have 20, 11 and 22. So now again we'll move to the next comparison. Okay, so it's like 92 and 20 will be compared. So again here it requires sorting. So both the elements will be swapped. So here 92 will come, and here 20 will come. So again in this subarray list, again it is going to do that sorting. Okay, so 5, 20 and 50. So again now we are going to see 92, 11. So again 11 is smaller, so swapping is required, and then it will be interchange its position. So here 92 will come and here 11 again in the subarray list. So again elements will be in sorted order. Okay, so again next comparison will be 92 and 22. So again swapping will be done. So this 92 will become last element, and then so 50 will come, sorry, 22 will come here. Again this will be sorted. Okay, 22 and 50 it will compare. So again it is smaller, so again it will change its position. So now if you do, so all the elements are in sorted order. So further no swapping will be done. Yeah, so this is about insertion sort. So yeah, thank you so much.